Polynomials. Yeah, those of you who take, anybody here take an English class?
Nope.
No? Latin even?
Nope.
The word poly,
Yes.
poly means what?
We don't know that yet.
What?
Polygon.
Poly means many. And polygon means many sides. This is Latin for you. No, this is Latin, right?
I
Poly.
know.
Polygon.
Polyester.
Yes, polyester. Many esters. And esters are kind of like a chemical thing. Polynomial, many, a nomial number. Many numbers. So they went on over in there. Many numbers. So if a polynomial is many numbers, what's a monomial? Monomial. One number. One number. So here's the official definition. Ready? A monomial is a number. That's a monomial. That's an example. A variable. That's a monomial. Or product. What does product mean? Multiply, right? A number. Let's pick a number. And one or more variables. Okay, here's one or more of them. With whole number exponents. What's a whole number? 1, 2, and what else? Whole numbers also have 0. Can I have negatives with whole numbers? They become integers, right? So these kinds of exponents. And you have a mono by definition. Nothing magic, it's just a definition. Okay? Monomials have degree. And a degree is basically says how many variables are there in this monomial. How many variables are in this monomial? None. There are 0. That's its degree is 0. How many? Well, yes, it is its exponent. If I write 5 like this, is this 5? The degree is the exponent. 0. What? How many variables do I have here? So its degree is 1. Now be careful here. I see 2 different variables, but how many instances? I've got 1x and I've got 5y. So how many variables? 6. This is degree 6. Not hard. Just new. Just new. It's amazing how the brain works. It's like we overload it and then like the next day it's like, oh, it just comes. Well, don't overload. Just, relax. Relax your brain for a second. But listen anyway. So I'm going to ask 2 questions. The first question is it a monomial? Is 8 a monomial?
Yes.
Yes. Because by definition, numbers are monomials. Is x a monomial?
Yes.
The variables are. What about this guy?
No.
Why not? I can divide. But if I rewrote this a different way, 2/3 x squared. What do you think, Sean? Well, product means, am I multiplying this number times that variable? Sure. That's a product. When they're right next to each other, there's no sign. That's a product. It is multiplied. Why is this yes? What has to be a whole number? The exponent? Does the coefficient have to be a whole number? No, it just says number. This needs real number. Is 2/3 a real number? Yes. Is it multiplied times a variable with the whole number exponent? Yes. It is a monomial. Yes. Okay. Thank you for asking that. She wants to know an example of one that isn't. This one is not. Because I can rewrite this like this, can't I? Are these equivalent? Is this a whole number? No. So you can't have x's in denominators and be monomials. Because we just learned all about negative exponents. And you see me do this example. The thing to take away from this is, if you have variables in a denominator, it's not a monomial. Yes. Well, I rewrote it. Isn't this the same thing as 2/3 times x squared? Can you multiply this? And 2 times x squared is 2x squared. I put it over 1. 3 times 1 is 3. It's the same thing. Yeah, it's the same thing.
Why is he not a monomial?
Because I can't have x's in the denominators, because if you write it like this, you see my negative exponent? It's not a whole number. Whole numbers aren't negative. So no. This one. Yes or no? What do you think?
Yes.
No. Why not?
The exponent.
number, it can be a real number. All these things have nice, lovely looking exponents, whole number exponents. Now let's look at degree. What's the degree of 8? 0. Think of it as 8 times x to the 0. Right? It's got an exponent of 0. Or how many variables do you see? I don't see any variables. I see 0 variables. What's the degree of this guy? 1. What's the degree of this guy? 2. Don't worry about it, right? Not a polynomial, I don't have to take its degree. What about this guy? Be careful, be careful. Well, I have to count how many I have. So I've got 1 here, I've got 3 here, that's 4. Got another one here is 5. 4 more, 9. Degree 9. Wow. Yes, ma'am. Emma, what do you think? 0 degree. How many variables do you see? 0 of them. And if you were to you can look at just the exponents. This is 8 times x to the 0. So what's the exponent? 0. So it's got, numbers have a 0 degree. Numbers have a 0 degree. Huh? How many variables do you see? How many variables do you see? So you have to kind of multiply them out. There's really 3 of these. There's 1 of those, 1 of those, 4 of those. So you're adding the little exponents up. Okay. Polynomial. Oh, we made it. So a polynomial, we had to learn about monomials because it's in my definition. So what is a polynomial? It's a monomial. Remember what a monomial is? A number, a variable, a product of numbers and variables with whole number exponents, or the sum of monomials. I know a certain person who used to live in my house and now is at college who got very upset by this definition. He said, how could a polynomial, how could a monomial be a polynomial? Polynomial says many, monomial says 1. Didn't like that. I had to tell him, I'm sorry. Sometimes we just got to give it up. Monomials is a polynomial even though there's only 1 of them, just by the definition. But it could be the sum. This is a polynomial. Or this is a polynomial. So all of these monomials, if you add or subtract them together, that makes up 1 polynomial. Each one of these monomials is a term. So when I say, how many terms are there? How many terms are there? 3 terms. You're basically saying, how many monomials are there? What are the terms? X, y squared, and negative 4xy squared. So include the sign with it if it says, what are the terms? What else do we have? Degree. Oh, degree. So we're going to make this confusing for you. Now, you ready? All right. Degree of a monomial is how many variables are in that monomial. So to find the degree of a polynomial, you find the degree of each of these guys and take the biggest one you find. So, what's the degree of x? What's the degree of y squared? Careful now, the degree of 4xy squared. 3. What's the biggest number? 3. That's the degree of your polynomial. That's it. So this is a 3rd degree polynomial. Not that bad. Everyone's a polynomial. No. All right. 8. Is this a polynomial? Yes. X plus 7? Yes. This guy? No, why not? Variable in the denominator. This guy? Yes. Okay. Now what about degree? What's the degree of this guy? 0. Degree of this one? 1. Because this one is 1, this one is 0. Take the biggest. Don't have to worry about you. Oh, all right, let's find the degree of all of them. What's the degree of this? 4.
8.
What's the degree of this? 4. I've got an X and 3 Y's. What's the degree of this? And what's the degree of this one? What's the degree of the polynomial? 4. Take the biggest number. It's a magnitude thing. We're trying to get an idea of the magnitude of this polynomial. No bigger than a 4th power. So the degree is 4. So do you have like central parts like you do about this plus this plus this? Yes. Biggest degree. That's not what I'm interested in. The degree is telling me a magnitude. How big can this thing get? The biggest thing I get is to a 4th power. And that's what I'm interested in. All right, we shall continue this afterwards. Yeah. So we're back. We're working with our monomials and our polynomials. So let's see. Other little conventions. Standard form. Remember standard form of a line? Right? So polynomials are going to have a standard form as well. So let's kind of talk about that a little bit. How does it work? You order the terms in descending degree order. What? Basically, the bigger the exponent, it goes first. So exponent order, but going down. So the x to the third, the x squared, the x in the number. So we always put it in that order. The degree then will always be that first term, because remember it's going to be the one with the biggest number of variables. So to find the degree, you basically are going to look at your leading term up here. So what's the degree of this polynomial? It has degree 3, because there's 3 variables up here. This number here, they're coefficients, right? Do you know what coefficients are? Yeah. Coefficients are the numbers up front. This one has an invisible one. Its coefficient is 1, negative 5, and 12. The leading coefficient is your leader, right? So the 2 is the leading coefficient of this expression. So let's put this polynomial into standard form, meaning degree order. This is on your paper there. It's kind of in the middle-ish. So which of these monomials has the highest degree? Negative x to the third power. So we're going to put that first. That becomes negative x third. Then what? Because how many variables are here? 3 of them.
Oh, the minus sign.
Right? And the minus sticks with it. The minus sticks with it. Then what? Who's got the next highest degree? 15x, and he's a plus, right? He's a positive number. And then what's my smallest one there? That plus 3. So this is the standard order. You put it in degree order just like this. Biggest first, and then the smallest. What else do we need to know here? So the degree of this polynomial right here is 3. What is its leading coefficient? Negative 1. Good. What question? Leading coefficient is the first coefficient up front. So this one, a negative, the invisible one, negative 1. Leading coefficient. Negative 1. Right, no, don't put the x there, just the negative 1, the number.
Why did you put the negative x 3 in front of the
Because I want them in descending degree order. So the bigger exponents come first. Bigger exponents first. Okay. What else? Okay, we have special little words. If you have 2 terms in your polynomial, we call it a binomial, by meaning 2, like bisexual, those kinds of words. If you have 3, what do you think we're going to call it? Trinomial. 3 terms are trinomials. So I'm going to be using words like this, so we just have to know what we're talking about. If I do use them and you don't know what I mean, just raise your hand. You can repeat it, not a problem. Okay, so now this is like what I want you to do here, and I'll show you what you're going to do. You're going to look at the expression. Everybody see this table in their notes? Yeah. So is 9 a polynomial? Yes. What is its degree? And how many terms do you see? 1. Okay, so do you understand what we're doing with these? Tell me if it's a polynomial. If it is, find the degree and the number of terms. If it's not a polynomial, tell me why not. So take a second and just kind of fill in this table. Just take a couple of minutes there. You're not all finished, but let's kind of do it now together if you didn't quite finish. Is this a polynomial? Yeah. How can we tell? Somebody like, how do you know? How can you tell?
You can.
How do you tell if it's a polynomial or not? How do you tell? There's no negative exponents. They're all whole numbers. Multiplying. Yeah, I don't see any reason why not. What's the degree of this guy? 2. Why is it 2 and not 3? You take the biggest one. This has a degree of 2. This has a degree of 1. And this has a degree of 0. What's the biggest one we found? 2. How many terms? 3.
Wait, how many?
Trinomial. Yes. What? Terms are how many monomials? How many things are you adding or subtracting? 1, 2, 3.
So is the 2x to the 7th, is that one thing?
That's a term. This positive x is a term, and the negative 5 is a term. How about this guy? 6 and no. Why not?
You have a variable number.
Well, I can't raise to a variable exponent. What about the square root business? Can't have that. A square root, believe it or not, you may not know this, but it is a fractional exponent. N to the half is really the square root of n. This is not a whole number. So you can't have a variable exponent, you can't have a variable square root. How about this guy? No, what's wrong with it? Negative exponent, that's not a whole number. Can't have a negative exponent.
Yes.
Yes, how come?
There's no negative.
No reason not to. What's its degree?
8.
8. Well, what is the degree of this monomial? There's 5 b's and 3 c's. There's 8 variables. There's 5 here, right? So you take the biggest one. And how many terms? 2. 2 different terms. Yes? No.
Good.
What's the matter? Oh, what's that?
Wait, how is that trinomial is receiving a 3? It's 3.
That's 5 plus 3 is 8.
You're adding the exponents.
No, but we're also getting trinomial, right?
This is a binomial. There's only 2 terms.
So did it see a 3 then?
No, a binomial or a trinomial means how many terms? How many terms are there? 2. That means it's a binomial. This just means you have 5 factors of b and 3 factors of c. You've got 8 factors of variables. 8 of them. That's what it means.
Wait, how come there are only 2 terms?
Because this one's got a degree of 8. There's 5 b's and 3 c's.
Why is it that the 7BC is 1 and the other one?
What?
How come there are only 2 terms? What are those?
This is one of them. 7b to the 5th is the 3rd. That's one of them. And this 4b to the 4th c is another one. So how many things are you adding or subtracting? 2 things. Alrighty. Adding and subtracting. So yes, polynomials can be added, subtracted, multiplied, divided, cubed. Right? You can do everything you want with these things. Yay. So luckily, you know how to do this. You really do. You add polynomials by combining like terms. Who can describe the process? What is combining like terms? What's a like term? What's a like term? Right. So if you have 2x plus 3x, how many x's do I have? 5 x's, right? We're adding them. But what makes a like term? You might want to note this. If you have the same variable and exponent combination, you have like terms. Anybody writing that down? No. Nobody. Write it down. Because some people get confused about what's a like term. For example, if I have x squared y, say I have 4 of them, and I have 2 xy squared, are these like terms? Yeah. Same variable, exponent combinations. Why? What's different about them?
Because there's the 2 in the middle of x1.
Right. So even though I have the same variable, this x is squared, this one isn't. This y isn't squared, but isn't. Not like terms. Yes.
But if 4xy has a 2 at the end, is the answer be 6x1 squared?
Are these like terms?
No, I'm taking the 4.
Right. Are these like terms? I got 4x squared y squared and 2x squared y squared. Those are like terms. So the same variable and exponent combination. So you can think of this as a unit. I think of these as we're going to call that the tori. So if I have 4 tories and 2 tories, how many tories do I have? 6 tories. Right? You're adding. Yeah. Right. Well, then because you got to think of them as like units. So they have to match. Variables and exponent combinations match.
And you don't add the exponents together?
No, because again, do I change the tories? It says how many tories do I have?
17.
6 of them. So how many x squared, y squareds do I have? 6 of them. So they don't change when you add. When do they change? When you multiply, right? Adding is kind of like, think of them as apples, tories. I like tories better. Okay, so let's look at adding, subtracting. And this is greatest because it looks so hard. So not hard. And I know you've done this. Now look what's going on here. Minus, plus, 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 minus. Do I even need these parentheses? Really? They're not doing anything. If you want to take them apart, you can. You don't have to. But sometimes it's a little bit easier to see. Optional. Okay, so I am looking now to see if I have like terms. Let me start with this guy here. What is the thing I'm looking for? X cubes, right? So do I have any more x cubes? Oh, look, here's one. Oh, here it is. Sorry, wrong one. Here it is. So if you have 2 x cubes and another x cube, how many x cubes do you have? 3 x cubes. Done. Because some people like crossing out. All right, now here's some x squared. So this is another kind. I'm going to use my diamond shape on the x squared. Any more? There's 2 of them. There's one right here. Now notice when I circle or make a shape, I include my sign. Include your sign. So negative 5x squared plus 2 more x squared. Pretty accurate. Negative 3x squares, I'm kind of done with those. My x, I'll use, I guess, a rectangle. Any more x's? No. So nothing to combine. And I'll use a low part. There we go. Any more of those? No. And check here. Yes?
What are the shapes?
Well, just because those are my like terms. So the circles match, my diamonds match, right? That's what I'm using different shapes. You don't have to.
Okay. All the shapes.
Yeah, the Tory. That's our new unit. And there we go. And you just check, do I have any like terms left? Did I find them all? Sure did. Done. I've added. Wait, where am I waiting? Yes.
Don't you need the parentheses? How can you do that?
Because this is really like a 1 in front. If you distribute a 1, doesn't it get rid of it? Now, if there had been like a 3 in front here, I would have to distribute that first and then add. Right? But there wasn't, so I don't have to. Just like there's nothing going on here. I really don't need the parentheses. So I can do it from here. You can rewrite it or just do it from here. So if you have 3x squared and another x squared, 4x squared. Let's see, I've got some x's. There's one of them. 1x plus 4 more x's. Those are 5 x's. And then minus 6 plus 10. I just said it. It's easy. Yeah, I'm telling you it's easy. I told you, you know how to do this. This is not new. You've done combined like terms. Alright, now here's a little wrinkle with subtracting, and it's not hard. But subtracting, I've got a lovely little binomial here, and I'm subtracting a trinomial. What's the matter? You guys okay?
What?
What's the matter? Where did I lose you?
So are we still combining the terms?
Combining like
together?
terms.
Yes. That's all. Now with subtraction, we're going to distribute the negative first. Remember distributing negatives? What is distributing a negative going to do to everything inside here? Flip the sign. So let's go ahead and do that. So that becomes a positive 2x squared, a negative 2x, and a positive 4. Because subtracting flips your sign. And once you've done that, it's just what we did before. So look for, where are my x squareds? Okay. 4x squared plus 2 more x squareds. Oh, here's some x's. We've got a diamond. I only see one of them. I guess that's minus 2x, right? I'll make my low parts here. Plus 5 plus 4. Done. Subtracted. Done. Is this so terrible?
No, it's fine.
No, it's not a big deal.
So what
I love my polynomials. Alright. Here's another minus. We're going to calm down. 4x squared minus 3x plus 5. Minus what? Minus 3x squared plus x plus 8. What am I doing? I'm flipping all the signs. When you subtract, flip your sign. Now let's see our like terms here. And again, circle with the sign. 4x squared minus 3x squared. X squared. X squared. Let's see, what have I got here with my x's? Minus 3x plus an x. There we go. And that's my low parts. Plus 5 plus 8. 13. Okay. Alright, so that's it. Adding and subtracting, you know how. That's all there is to that. Say two. Wait, we're not quite done yet. She's like, please be done, please be done. No. Part of it. Because what comes after adding and subtracting? Multiplying. Woohoo. You know how to do this too. Honestly, you know how to do this. I'm going to start looking at a monomial times a polynomial. So one term times multiple terms. Distributive property. Remember that guy? How does it work? If I've got 5 times x plus 1, how do I distribute? Yeah, I'm just reviewing distributive property because that's how you multiply. So a monomial, right? One term, here it is. And here's my polynomial. I've got 4 terms here. So what do I do? Distribute it. Now this is where our work with the exponents is going to pay off. Because we're not adding now, we are multiplying. So 2x cubed times x cubed. X cubed times x cubed. How many factors of x? 9. Alright, 2x cubed times x cubed. Think about what this is. There's 2x times, I'm multiplying, right? 2x. How many factors of x? 2x. 6. It is confusing between adding and multiplying, so be really careful. Multiplying is telling how many factors of these do you have. If you have 3 factors here and 3 factors here, add the exponents. Adding and subtracting is how many Tories do you have. Okay, they're different. Alrighty. What about now we're up to 2x cubed times 3x squared? What's that? Multiply the numbers. 2 times 3. 6. We're multiplying. Multiply. 2 times 3.
But when we added the last one.
But I'm not design exponents. They're actual bona fide real numbers. 2 times 3.
So if you have the coefficients, you multiply that.
Yes. Multiply coefficient.
Add the exponents.
Yes. Alright. Okay, wait. Let's do this one. Up close and personal. We used to do that on the Olympics. I'm not going to do that. Alright, so 2x cubed times 3x squared. Aren't these all multiplies? Let's change the order, shall we? What's 2 times 3? X to the third times x squared. How many factors of x? 5. Thank you. But we're distributing, we're multiplying. These aren't bases, these are coefficients. It's 2 to the 1, right? They're coefficients. 2x times negative 2x. 4x to the what? 4. I've got 3 here, because here's 3 factors, here's another factor, I've got 4. Okay, 2x cubed times 5. Now what we got? And when you're all done, you should kind of check. Sometimes you can combine like terms here. I don't see it. That was multiplication. That was an easy one. Easy. It was. Okay, now. Did you see it? Oh, it's going. See what we got? It's going. Yeah. And the Tories are now forever. All right. Multiple distribution. Now, when you do these guys here, let me get a little closer here. Notice how this is a binomial, so this could have been a trinomial or more than that, doesn't matter. You do multiple distribution, which means you cover up this -4, you cover it up like it's not there. And then you're going to work with just the x. So you pretend this guy's not here, and then you distribute the x. When you're done doing that, you pretend this x isn't here. You're going to cover it up. Notice how I'm not covering up the sign. So that -4 now gets distributed. I'll put it under it. And everything gets multiplied. Double distribution. So I've got like some words here to that effect. So let me just distribute and combine like terms. So you cover up the -4. So what's left? X times 3x plus 2. So let's do that one. Here we go. X times 3x.
4x.
No, we're not adding. We're multiplying. 3 squared. Multiplying. 3 squared. Times. Because you have x times x. Yeah? Alright. X times 2. Thank you. Okay, now we did our x's. Cover that guy up. Just look at the -4. So now we're doing this one. What's -4 times 3x? And then what's -4 times 2?
Oh, so you add the two things together.
Well, we are now, right? Because I see like terms. Who sees like terms? Behind the 12.
Then x minus 12
3x squared plus 2x minus 12x minus 8. So can I combine these guys here? Yeah, absolutely. So my 3x squared, nothing I can do with it. What's 2x minus 12x? Minus 8. So this whole product is 3x squared minus 10x minus 8. Multiple distribution. And if there had been more stuff, like, you just do the same thing. So I'll just add another one. So except we still can't work with the exponent. Now, if you have more than 3 things, you just do that one, do that one, do that one. Do that one, do that one, do that one. What if I had like another thing up here? I just got another set to do. So you're just doing as many distributions as you need to distribute all the pieces. Yeah. not really, but try to be organized. So I'm always like, if you have three things up front, yes, do the first one first, whatever. So cover those up, x squared. Then do the x's, then do the minus 4s. Oh. FOIL. It wouldn't be algebra class unless we talked about FOIL. FOIL is an acronym. What's an acronym? One person, tell me. Claire, what is an acronym?
Like each letter stands for.
Think of an example of an acronym? Besides FOIL? PEMDAS. Kind of, okay, right? Same idea. FOIL. This one stands for They're reading the notes. I was like, what? How would you know this? First, outside inside class. This FOIL has been around forever. It's been around for at least 200-300 years because when I took algebra, we learned about FOIL. I'm about 200-300. It feels like it some days. I'm a vampire. No, some days it feels like it. So, acronym. So what this means is when you have two binomials, I can't remember what the last one was. I'm going to make up a new one. No, it wasn't that. I'm making up a new one. It was 3x. It's a different one. Here we go. New example. So what does this mean? It says multiply the first in each binomial. Multiply those guys. Then it says do the outside ones. Well, here's an outside one. Here's an outside one. So it's x times -2. Okay, now do the inside. Well, see, these are the insides right here. And then do the last one. If this makes no sense, it actually does not matter. Just use all three distributions. And then combine these. And I have it. Now this one, the first time you see it, it's like, what? No. But it actually is handy. It's handy. We call it the FOIL happy face because it kind of makes like a little smiley face. So the reason you need to know this is because guaranteed, excuse me, I'm speaking. When you get into algebra 2, I can almost hear the teacher saying, okay, well here's two binomials, go ahead and FOIL them. It's become like a verb. So you just need to know what it is. If this is like, I don't want to do that, cover up the 4, multiply the x's, cover up the x, multiply the 4s. Because that's what this does. Right? So don't worry about it. If you don't like it, it's okay, you don't have to. But it's just a way to remember how to get everything. And I'm trying to think here. So you try. Alright, people, let's do some together before you try. A. Shall we? Alright, I'm going to do A with you, right? It's a monomial times a trinomial. How do I do it? One word, answer. Distribute. FOIL does not work for this. Yeah, FOIL works for two binomials only. X, you just got to answer anything. X times 2x squared. 3x. Oh, multiply. And how many x's? Cube. X times -3x. Multiply. Think of the one in front of you. 1 times 3 times x times x. X times 9. And I had multiplied. You can't combine, right? What? Can I combine anything? No like terms. Yes, ma'am.
What's the lie we do this?
You will find out. Oh, the world goes round multiplying polynomials.
What are some things in life that you use?
Why did you learn your ABCs? It probably was very pointless in kindergarten to learn those ABCs.
I use my ABCs every single day.
Well, if you are a physicist, you use this every day. You might be. All right. Let's try this one. -8 to the 5th. Be careful with negatives. Negative times a negative is a positive. 8 to the 5th times 9a squared. What is that? 9a7. Negative 8 to the 5th times a positive 5a. What's the sign going to be? Minus. Okay, what do we get?
5a cubed.
2 to 6. This is a 5. This is a 1. So you have 6 factors of a. Negative 8 to the 5th times 24. Minus 4 to 6. 24, 5. There we go. Let's have it.
Yeah, no.
All right. And now let's look at this guy. Now this is a binomial times a binomial. Multiple distribution. Guys, so pretend 2 isn't there. Now we're just going to distribute the x. X times x. X times x.
X squared.
How many factors of x? X times negative 3. Okay, now I'm done with the x. Because he's not there, now let's distribute the 2. 2 times x. That we can do. 2 times negative 3. Alright, can I combine like terms?
Yes.
Absolutely. The minus 3x plus 2x is? Minus 1x or minus x. Simplest form. Minus this. I call that the oi and the foil because it's the outsides and the insides. They tend to combine. The oi and the foil. The outsides and the inside very often will combine. Now it's your turn. You do D, E, and F. We'll go through. Okay, the answers are here for you to peruse. Be careful that you multiply and not add when you distribute. Wait. Wait. Sit down. Thank you. If you want these to see them more fully in the class summary, I've got everything